So approach in the measure phase. Collect the baseline data on defects and possible causal factors. Then we need to see the trend, the graphical analysis of data. When we had this COVID pandemic, when all of them gave big data on state-wise numbers, but if you saw the trend of that, that gave a better picture to you. And we need to plot the data over time and analyze for the special causes. Generic example, and particularly in this COVID pandemic, we plot the defect data over time and analyze the special causes. Now we have analyzed another special cause of this pandemic. What is that new virus called? Yeah, Omicron. Okay. Then we try to put the data into the form where we can make sense out of the data. We'll talk about the tool called stratification, frequency plot and histograms, Pareto analysis, and we'll talk about many such tools, okay? All right, and then we will calculate what is called as a sigma level. Calculate the process sigma. Now, this word can be very, very scary for you, process sigma. It is very, very simple term. Let's say that, you are in a hall where there are no furnitures. Imagine, all of you imagine a big hall, okay? And in that big hall, probably, 30 feet by 30 feet, okay? A big hall, okay? And then you stand in the center of the hall and draw an imaginary circle around that in the hall. And then you have a handful of marbles. Now, when you drop the handful of marbles, probably 50 marbles, at the same time, what the marbles will do, it will fall down and scatter all over. And now you are in this 30 by 30 room or 50 by 50 room, you have drawn a big imaginary circle. And from the center point, the marble has scattered, with respect to the center, it has scattered all over the place. And you can imagine that some marbles will be closer to the center and some marbles will be very far from the center. Now, if you have to measure the distance from the center to that marble, and similarly, measure the center to each and every marble. Let's call marble 1 as x1, marble 2 as x2, marble 3 as x4, x3, x4, x5 up to x50. Let's say it's 50 marbles. So everything is varying, correct? And you calculate this, if you square that and then square root. 2 square 4, right? And square root of 4 is how much? 2, okay? But what I'm trying to say is, if you are trying to measure the distance, some would be on the positive side, some would be on the negative side. Yes or no? Like you draw the axis, x-axis and y-axis, some would be on the positive side, some would be on the negative side. And so, if you have an average of all that, you have calculated these distances, you sum up all that and divided by the number of marbles, you have calculated the average, and then you check out with respect to average, how much each marble is deviating. And some might be deviating in the positive side, some might be deviating on the negative side. But you can't do a square root of negative, and that is the reason. You square everything, add up everything, and then do the square root. And that comes the formula of standard deviation. And that is called as sigma. This is called as RMS concept. Root means square, way of representing, okay? So people who have to solve problems using Six Sigma methodology should know basics of statistics. Okay, so calculate process sigma. and then create detailed process maps.